Hello everyone, my name is Ashik and today I'll be showing you how to perform advanced static analysis using IDEA Pro. Our setup here is basically VMware and running Windows XP Service Pack 3 on it. So to start off, all you have to do is click IDEA Pro, click OK, disassemble a new file and click on P executable. Then you have to locate where your malware is, and our malware is located in a UPX folder, which is basically used to unpack malware. I think my teammates already performed the packing, and now I'll just show you how to perform advanced static analysis on it. So you click on malware, click override, click next, but start analysis now. Here you are presented with the graph overview of the malware. So to look at the main subroutines, just click xrefers and click 1, the recursion depth of 1. As you can see, this graph is very messy, but we do get outside information from it, valuable information. There's a major subroutine called start and Windows main. This will basically guide us into knowing what the malware performs. So you click on start from the functions, and here you're presented with what start does. So the main thing start does is calls get version. What get version does is basically gets the current version number of Windows and information about the operating system platform which the computer is running on. Additionally, it calls heap init, which leads to the creation of memory for the malware to operate. So let's click on heap init. Yes. So what heap init does is create a heap which is used by the malware. So it creates, the first call heap init makes is heap create, which basically creates the heap. It has 3 variables: DW initial size, DW maximum size, and FL options. As you can see, the DW initial size is 100H, or when you convert it, decimal is 4096 bytes. Yeah. However, the heap is not limited to 4096 bytes, as the DW maximum size is 0. This means that the only limitation is the amount of available memory of the system. If the creation of heap is successful, if you follow the line here, it will bring us to location 401F6A, which basically returns it to the start subroutine. However, if it fails, it will call out SBH heap init. This again just calls out heap allocation, which basically tries to allocate memory for the heap. If the memory allocation is a success, it will go to location 401F6D, which I will show you later, which returns the program back to start subroutine and ends the heap init subroutine, right? As you can see. However, if the memory allocation fails, it will call out heap destroy, which basically destroys the heap and releases the previously reserved memory for the heap back to the operating system. Then it returns back to the start subroutine and calls out fast error exit, as the malware has insufficient memory to operate. Now let's look at the previously mentioned 4014F7. So in 4014F7, if the jump is true, it will come here, right? The jump if not 0 is true, it will come to this subroutine. The first important call it makes here is get command line A, which gets the command string for the process, sets the argument variables from here, sets the environment parameters, and gets the startup information of the OS. Yeah, here, startup information for the OS. Lastly, it calls out the command line using _win_cmd_ln, which is the Windows command line. Now let's go to subroutine 4, which is 401547. In 401547, it calls out get module handle A, which gets the module handle of the sought malware. The next call it makes is the Windows main at 16, before calling. Now let's take a look at Windows main at 16. As you can see, the first main call it makes is get Windows directory A, which allows the malware to reach the Windows directory of the host computer. Then it pushes the offset of string 2, which contains syslog.exe, into the stack. After that, it calls lstrcat A, which changes the value of the stack together. This forms the file location for the malware to copy itself over in a later call, copy file A. After copying itself, the malware will proceed to edit the registry. First it pushes the offset of the subkey, which contains software Microsoft Windows current version, and run into the stack. Following that, it pushes the H key, which is basically the handle to the registry key, with a value of 0x80000001H, which refers to the H key of the current user HKCU section in the registry. Then it calls out reg open key exa to open the path of the registry. After that, it pushes the offset of the value name Microsoft syslog and then the H key before calling reg set value exa. So what this does is that this will run the malware which the current user logs on. So now let's look at subroutine. The next subroutine, which is 401184. So in 401184, Windows main and 16 will eventually release subroutine, which is where the malware configures its own network settings to be able to connect to the malicious server. To be able to do that, the malware starts by calling WSA startup, which has two main purposes. First, it allows the malware writer to specify which version of WinSock he wants to use, and more importantly, load up WinSock DLL into the process. On top of that, it starts off Windows sockets, which indicates that the malware wants to establish a connection with an outside host, which in this case is probably the malicious server. And after that, so that is basically the function of WSA startup. So after that, what this subroutine does is call WSA socket A, which is to create a socket that's a specific transport service provider and gets these properties in order to be able to create a socket. So after this, it pushes EDX, which basically contains host short, a 16-bit 2-byte or 2-byte number in the host byte order, and calls out htaunts, which is basically a function in WSA socket A. What this does is that it converts the host short value from host to TCP IP network by order, big Indian, in other words. After that, it calls out the init address to convert a string containing the IPv4 to convert the string and turn it into an actual IP address. Due to the limitation of IDA Pro, I was not able to find out what the IP address was, but I had to refer to my teammate and I got the IP address. Now, let's look at our final subroutine, which is location 4011E9. So at first glance, you can tell that it's a recursive subroutine due to all these loops. And you're right. The first thing this subroutine does is attempt to connect to the IP address which it obtained previously by using init address. If the connection is not secured or the connection attempt fails, it will sleep for approximately 300, no it's not, it will sleep for 30,000 decimal seconds, which is converted to 30 seconds. And after that, it will try to connect to the server again. In the case of succession, however, it will create a process A, which uses the command line, you can see here, it uses the command line to create a running process for the malware. This allows the keylogger to transmit the log keystrokes to the server in real time. Finally, it reaches endpoint and ends the procedure. I hope you learned something from this tutorial and see you again. Thank you.